Hello, everybody. Here we are, 6.2. It's snowing outside. It's a snow day, and I'm recording this at my house. Anyways, we are doing solving equations by balancing strategies. So this refers to section 6.2. I'm going to, I think, do this video, and then I'll have you do some of this sheet in class because there's a few things that I should probably go over, I think, a little bit more in depth. So I'll have some kind of in-person lesson, like, this stuff right here, some of this stuff. But these are the notes that I'm going to give you on the video at least. So this section primarily looks at algebraic equations that involve variables on both sides of an equation. Okay, so if we look here, we have, a c on this side, and we have some c's on that side. And it's going to be looking at rational coefficients. So, for example, like if we have fractions like this as our coefficient. So this section, primarily going to look at that. And they introduce this idea of balancing. And so I'll keep on reading. Variables on both sides of the equation. Let's look at this part. So step one, combine like terms by bringing the variable to one side of the equation and the constant term to the other side of the equation. So we want all of our variables on one side and all of our constants on the other side. The next step is to isolate the variable by dividing both sides of the equation by the variable's coefficient. So I'll show you what this looks like. Because it's thinking about balancing, I'll draw this out for you and just show you what this would look like if we're thinking about it balancing, if we're thinking about it being like a scale. So I'm going to draw my 3 negative c's and the 7 positive ones. So it looks something like that. And this is going to be equal to, we're going to have 2 positive c's and 8 negatives. So these are all negative. 1, 2, 3. I need one more. Those are all negative. And this is saying, like, imagine we have like a scale, okay? So we have like a scale like this, like this. This is not a very well-drawn scale. You can think about a kitchen scale, and these weigh kind of exactly the same amount. So what we have to do to one side, we have to do to the other, or else our scale would come out of balance. So I want to start with thinking about, I like to have positive variables. So I would like these negative 3's to kind of be over here. So what we're going to do, we want to add 3 positive c's to each side. So I'm going to add 3 to this side, and I'm going to add 3 to this side. So the balance of this thing has not changed, okay? We've added the same amount of like weight, let's say, to each side. So this hasn't affected the balance of our equation. However, these things, remember, have just become 0 pairs. So this is kind of zeroed out, this is zeroed out, and this is zeroed out. So those are kind of done with. But these ones now remain. So then we could think about moving our 8 negatives to the other side. So what we can do is add 8 positive 8s. This is a lot to draw to this side. And we need to balance it by adding 8 positives over on this side. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now again, we have made these into 0 pairs. So even though the balance hasn't tipped, okay, we added the same amount of weight to this side and the same amount of weight to that side. These have now kind of zeroed out. And what's left in all this mess? Let me do some erasing, and I will draw it more, perfectly pretty down here. We now have 15 of these ones over here, and we have 5 of these x's or c's actually over here. So I'm going to draw it like this. 1, 2, 3, 4, 5. And now we have 15 over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, sorry, I should be doing 3 in each row. That's my bad. So I'm just kind of dividing this 15 evenly amongst these 5 rows. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So we essentially have 15 equals 5C. If we look at each of these rows, we can see that each of these C's equals 3. So our answer, we see equals 3. That's using tiles, okay? I know we don't always love tiles, and look at how much work that was. But that's maybe just to help you like conceive of visually and concretely what we're doing. And now I'll show you not using tiles, especially since, when we get to things like this, a point decimal, we're not really going to be able to use tiles anymore. And, it's not that great to have to draw 15 and 15. We're going to run out of room. So not super viable long term. So let's just think about balancing each of the sides. I want this to be positive x's. So I'm going to put our x's on the side where we have more. So I'm going to move our x's to this side, and I'm going to move our constants to this side. So let's subtract 4x from each side. I'm going to rewrite it. 6x subtract 4x is going to be 2x plus 2 equals 10. This positive 4x and this negative 4x cancel each other out. Now let's subtract. Let's move this 2 over to the other side. So let's subtract 2 from each side. We're left with 2x. That becomes 0. Equals 10 minus 2 is 8. And now to get the 8 by itself, we can do inverse operations. Divide by 2, divide by 2. And we are left with x. That's going to equal 1. X equals 8 divided by 2, which is 4. We can always verify our solution. I like to do that. So let's just go back. We can input our 4 into the x and see if that's true. So is it true that 6 times 4 plus 2 equals 10 plus 4 times 4? So 6 times 4 is 24 plus 2 is 26. Does that equal 10 plus 4 times 4 is 16? Yeah, it does. So 26 equals 26. We confirmed there that we did that correctly. I'll do a couple more. I actually might skip this one. I mean, I think I displayed that enough up here. I think that's a pretty good example. But I'm going to move on to number 4. So we have some decimals. We just do the same as we did, but we might not end up with these clean numbers like we have before. So I want there to be a positive x. I like to have a positive x. So since they're both negative, you could think about this one where we would add 5.7x. And that's going to bump this into a positive territory. So I'm going to put our x's over on this side. So let's add 5.7x here as well. I'm going to do that one quickly on my calculator. So we have 2.5 negative plus 5.7. That's going to equal 3.2. So now we've got 3.2x subtract 2 equals 6. This, remember, kind of zeroed out. Now let's add this 2 to each side. We're left with 3.2x equals, this is 0 again, remember? Now 6 plus 2 is going to be 8. Now to get the x by itself, let's divide by 3.2 on each side. And we get x equals, let me do this in the calculator, 8 divided by 3.2 equals 2.5. x equals 2.5. We can verify our answer if you'd like. So let's see, is it true that negative 2.5 times 2.5 subtract 2 equals negative 5.7 times 2.5? Oh no, I'm running out of room. Plus 6. I'm going to do this in my calculator. So 2.5 negative times 2.5 equals negative 6.25. And I think we got to subtract 2. So negative 8.25 on this side, negative 8.25. Does that equal, so negative 5.7, 5.7 negative times 2.5 equals plus 6 equals, there you go, does equal negative 8.25. So we did confirm that those are equal, and that's a correct answer. The next part is looking at rational coefficients. Fraction coefficients. What we need to do to solve these is get rid of the fractions by multiplying both sides by a common denominator. Okay. Next step, combine like terms and isolate the variable. So we have to think back to fractions a little bit. And this first one is a little bit more straightforward. I'll show you what that looks like. But this number 2 can be a doozy. And I will also kind of go over that with you in person when we get to a question like this. So this first one, we want to get rid of this. So we're going to multiply each side by r. So I'm going to write it down here so we got enough room. Divided by r equals 3. Let's multiply each side by r. Okay, this is going to end up becoming 1. Remember, if we have, say we had 122 r over r, we can remember from our last polynomial chapter that these would kind of cancel each other out. They become a 1. And that's going to equal, I'll show you right here, equals 3r. So we've got 122 equals 3r. Now to get the r by itself, we're going to divide each side by 3. So finally we get r equals 122 divided by 3. 122 divided by 3. I think we're going to get a decimal here. Yeah, 40.666 repeating. So 0.66 repeating. You could also show it as, if you want r equal 40. I know 666 repeating is 2/3. So that would be just our mixed number form.